Good evening, everyone. But we will be talking about 3D printing whitening trays. So for those that don't know me, my name is Luke Shapiro. I'm an orthodontist here in New York City. So just a little bit about myself. I went to high school in Brooklyn and then college at WashU in St. Louis, where I was, you won't believe it, a Spanish major. Besides Spanish, I did take all the pre-dental classes and was probably about 1 to 2 classes away from minoring in any of the major sciences. Right after college, I then came back home to New York and went to Stony Brook for dental school. Go Seawolves. After that, I went to Boston for 2 years for my residency at Tufts Orthodontics, and now I'm practicing at Lemchen Salzer Orthodontics. Believe it or not, I was actually a patient of Doctors Lemchen and Dr. Salzer. They're not only my bosses, but also my mentors. Dr. Lemchen has always been an innovator in the field of orthodontics. He started Dolphin Imaging as well as EasyRx and Xenorobotics. Dr. Salzer was one of the first Invisalign doctors, and she's a very talented clinical orthodontist with a focus on TMD and airway. And then Dr. Lemchen, Andrew Lemchen, was my big brother at Tufts Ortho and literally taught me since the day one all I know about ortho. I also practice across the hall from my brother and dad, who are general dentists. Many of you will probably ask, why are you, as an orthodontist, making whitening trays for your patients? Won't your referring dentist get mad at you? Well, my brother and dad wouldn't get mad at me for that. Probably other things. But also, I'm more so direct printing whitening trays because I love 3D printing technology, and I'm helping out my brother and dad a little bit. Honestly, many of my patients that whiten their teeth do so concurrently with aligners and either use a foam or a gel with the aligners themselves. So, as I said, I'm not personally 3D printing that many. It's more so helping out my dad and my brother. So this topic, 3D printing of whitening trays, is actually accumulation of all my research dating back to middle school. In 8th grade, my big project was the effect of different whitening systems on teeth whiteness. I recruited friends, teachers, parents to use white strips, toothpaste, gum, and whitening paint to see which was the best. As you may have guessed, the white strips did the best job. In college, I took an advanced organic chemistry lab, and I tried to figure out what methyl methacrylates had the highest viscosities or fastest polymerization rates. I remember the chemicals were very sticky, similar to the 3D printed materials before they are cured, which I'm going to talk about today. So, as you know from the first 2 videos, 3D printing has been making huge strides. Take, for instance, this Safe Box. Did you know that you can actually download this file for free and then print the parts? There's literally an instruction manual that shows you which parts to print and how to attach them together. So why has it taken us so long to directly print whitening trays or aligners? First, I'd like to learn a little bit about all of you. I'd like you to ask yourself, or you can comment in the chat box, what is your experience with technology? Do you have a scanner or a 3D printer? If you don't, what's stopping you? Is it the investment to buy one of these or the training that would have to go into teaching you and your staff? And then let's talk about whitening. Are you doing whitening in your office? How are you making whitening trays? Do you order them from a company that then ships to the office in 2 to 3 weeks? Or do you make them in-house? I was thinking to myself, who are the people that will be on this webinar tonight? What side of the spectrum is everyone on here in the 3D technology world? I honestly don't know, but I hope that in this hour, whether you're a 3D printing master or still using Alginate, that you can take home a pearl or two. So, Went too fast there. So let's talk about 3D printers. I remember at the beginning of this whole 3D printing dental revolution, I thought to myself, why doesn't somebody create a guidebook or something to help dentists on what to purchase? I remember asking Dr. Brandon Owen, an orthodontist with a ton of knowledge on 3D printers. He actually has his own company called Clone Braces. And I was like, why don't you just make a book or something about this? And he said, because there are so many printers that are constantly coming out with new models, that would be impossible. And that was even more so back then. It's slowed down a little bit now, but I definitely agree. There are so many printers out there that fit certain dentist needs. For example, some dentists own multiple practices and need a workhorse of a printer that can run overnight to print many models. And some dentists only use printers to create surgical guides and night guards. In our office, when we first started, long before I was even there, they had a Stratus. The Stratus was a great printer. It had a huge build platform and was great to run overnight and print many models. It was one of the first 3D printers in dentistry. Then the office got a Formlabs and another Formlabs. And then we sold the Stratus and started to lease a Carbon instead. And yes, I did say lease because Carbon doesn't let you buy the unit. Rather, you lease it for 3 years. And then we have an Uptown office, and that one has an Envision Tech. And then we sold one of the Formlabs to one of my neighbors. And then we got another Sega Uptown. And then most recently, we got the D-Max, the rapid shape printer from DMG. So this is what the office looks like downtown. You have the Carbon on the left, the DMG printer on the right. They like to face each other. I like to think they're friends. And then we have the Formlabs in the back of the office, and where the coffee and microwave is where the old other Formlabs used to be. So there is some terminology you should be familiar with in the printing world. CAM stands for Computer Aided Manufacturing, and CAD stands for Computer Automated Design. In the case of DMG, the CAM refers to NetFab, the printing software, while the CAD refers to Dentamile Connect software, which is the program to make the whitening trays. In 3D printing, there are 6 main types of 3D printers and 3D printing technologies. In dentistry, we focus on 3 of them that are present in dental offices. The other 3 affect our dental lives, but a dentist would never really own one of those printers. For example, we buy 3D printed expanders that are made from a metal printer. I think that printer itself probably costs like $500,000. The most popular in dentistry are the fused deposition modeling, stereolithography, and selective laser sintering, all on the left. And of all those, I would probably say DLP, which stands for digital light processing, is the most popular of them all. FDM is cured layer by layer as the material is extruded from the top. This is the technology that Stratus uses. These build plates tend to be bigger, and they're used by labs. The SLS uses a laser to cure each point by point. The Formlabs use this technology. It's a little bit slower, but very accurate. SLA is when it's a line of laser that cures, while DLP is the whole surface. Most use DLP, as I said, like Rapid Shape, Joule, Envision Tech, and more. The Carbon is basically DLP, but they slightly modify the process to include an oxygen permeable layer, and so they call it digital light synthesis. Don't get me wrong, it's an amazing printer, but I think part of it's marketing to try and distinguish themselves from the other DLP printers on the market. DLP printers come in 2 types, inverted or non-inverted. The DMG 3D Max is inverted, so this means the top is actually the bottom. You should just be aware of this because later in the presentation, when I show you how to print the whitening trays, you will notice that supports will be needed. Supports are basically little poles that help prop up the tray or whatever is being 3D printed. Without supports, the stuff that is being 3D printed would fall off the platform since it would be too heavy to beat the force of gravity. In New York, we have lots of construction, and I always think of the supports as like scaffolding. Another topic pertinent to 3D printing is horizontal versus vertical. I feel like I see this in all the orthodontic Facebook groups. Guess what? For models or whitening trays, you can do either. The whitening trays can't be 100% vertical, but they can be at a slight angle. For me, the horizontal versus vertical debate really depends on your workflow and how much you need to print. For example, say you are in your office and you have a patient that was just scanned for whitening trays. You then want to deliver their whitening trays 1 hour later once they finish with their in-office whitening. Would you print vertically or horizontally? The correct answer is horizontal because the print will be faster. Now let's do another scenario. Let's say you own a lab and want to print as many whitening trays as possible overnight. Which would you do? Then you would print vertically. I really like this graphic here from Rapid Shape. Keep in mind, these are only printing times for the 3Demax. Every printer is different. And also, this is just a rough estimate. If you have a bigger mouth, guess what? It'll take longer to print. On the same line of thinking, a smaller mouth, or say somebody with less teeth, will print faster. Check out the comparison between two trays. You can do that in 20 minutes, or you can print 6 trays vertically in 50 minutes. Another thing too to add here is when you do 1 tray versus 2 horizontally, that would be a little bit slower, a little bit faster if you only do 1 tray. The reasoning is because the platform will weigh less. So the elevator, the mechanism can move a little bit faster, but it'll only be like an extra minute or 2 that you're really gaining. This is another thing to keep in mind when choosing vertical versus horizontal. Let's take the cylinder as an example. If you print it horizontally, then the smooth surface will essentially be impossible to get back. For whitening trays, you want to make sure you're adding supports on the correct surface. If you were to add them on the intaglio surface of the trays, then you could possibly have fit issues. I've been asking myself, does DMG have the first direct printed whitening trays on the market? I think the answer is yes. There are a couple of other direct 3D printed liners out there that are not quite yet on the market, so I'd like to give a shout out to them. Graphy. So these are aligner companies, not whitening trays. Graphy is a Korean company that uses its own printing system and curing system to create 3D direct printed aligners. The material is thermoplastically activated in the mouth, which means that you cool it in water so that it's flimsy. And then when you put it in the mouth, it stiffens and forms tightly with your teeth. I never tried it in my mouth, but I did see a demo of it and got to hold it in my hands at a conference. It reminded me of the heat-activated technology of various different orthodontic wires. I also found this Chinese company called Lux Creo in Google searches. I honestly couldn't find much about them and haven't seen them in person. So the reason I want to show you this is because the field is so new. In creating direct 3D printed aligners is like the holy grail in orthodontics. Envision Tech at one point also said they were direct 3D printing aligners, but I think they discontinued it. And I clicked on the website link and it said the page isn't available. So I am assuming they've stopped. Now, let's get into a few studies before we dive into the clinical. I'd like to start off with a quote from Dr. Robert Kiem from the 2020 Journal of Clinical Orthodontics. In my experience, the traditional impression procedure generated as much patient anxiety and complaints as anything we did. When I first started using an intraoral scanner, many patients expressed delight at avoiding alginate impressions, and practically every one of them commented on how cool the scanning was. While this is not a study per se on the intricacies of 3D printing, I think it is still a very important quote. This technology is cool and patients love it. There is not one patient that I know that prefers to have an impression taken of their mouth as opposed to a scan. Patients that have been scanned multiple times are still impressed by scanners. So yes, patients love technology. 3D printers are the new cool thing in dentistry, and patients are impressed when you say something is custom 3D printed for them. I now want to go to this article from 2016 entitled Validity and Reliability of Intraoral Scanners Compared to Conventional Gypsum Models, Measurements, a Systematic Review. This article is showing that scanning and traditional impressions are the same, all the way back in 2016. You know what that means? Scanning is probably even more accurate now. So if you don't have a scanner, go get one now. Just a brief aside on scanners. I honestly think we've reached the point where all the scanners are very comparable in terms of speed, accuracy, and precision. Our office mostly has iTero scanners, which I love. We do a lot of Invisalign, which is why we have them, because Invisalign only accepts scans from iTero. I also love the iTero for its patient education. I can show patients if they have potential cavities using the Near technology. I can also show patients what their smile could look like after Invisalign in less than 2 minutes. I can compare 2 scans over time to show recession progression or teeth shifting. My dad uses a 3 shape and he loves it. He does a lot of crowns and veneers and thinks it is best for that. I also know people that have the prime scan, which they love for milling crowns. And lastly, I know many people with a Medi that are super happy with it, especially since it is the most affordable on the market. And now that Invisalign is not the only aligner company, dentists can now use their scanners to order aligners from different companies or even fabricate their own. As for the Rapid Shape 3DMX, it is not a closed system, so you can use any scanner and export the STL file. So back in dental school, I did a research project on 3D scanning surface technologies. I basically tested the accuracies of different 3D cameras used in dentistry. I first started my project on the Planmeca ProFace, but as I wrapped up the year on that, research project, a new program came out for the iPad. So in order to make my project more up to date, I compared the ProFace, which is a camera integrated with the CBCT machine, and I compared it to the iPad. Then as I finished that project, Bellis came up with an app for your iPhone to scan your face. So what's the point of all this? That no matter how hard I tried, I could not keep up with the advancements in 3D photography. The same thing applies to 3D printing. If you look at this article from the Journal of Prosthodontics, it was published in March of 2022. But if you look at the disclosures, it was presented in June 2019. What does this mean? It's probably based on data from 2018. But yes, it says that the 3D printers are accurate. I would like to read this quote from the article, Direct 3D Printing of Clear Orthodontic Aligners, Current State and Future Possibilities from 2021. While it is not about whitening trays, I think it is a similar sentiment. Use of a clear aligner that is 3D printed for direct usage. Oops, there we go. Can eliminate the cumulative errors introduced from analog impression taking in the subsequent thermoplastic workflow. In addition to greater accuracy, direct printing produces other benefits such as shorter supply chains, significantly shorter lead times, and lower costs. It is also a more sustainable process that generates significantly less waste than subtractive and thermoforming processes. This is a very important quote as it touches on three major things. For one, accuracy. If we can direct 3D print something, it will be more accurate as it is that much closer to the source. Secondly, it will lead to less work and quicker turnaround. And lastly, it will be a huge benefit to the environment. Think about all the waste that we are spending on 3D printed models. Despite the current improvements and increased use of different 3D printing technologies, there's a limited number of publications that can be found describing the direct 3D printing of orthodontic clear aligners or research regarding suitable materials for such printing. Let's get into it. Time to start printing some whitening trays. So to do this, you'll need a scanner, the DMG3 Demex 3D printer, the 3D wash, and the 3D cure. You can also use your own ultrasonic bath or post-curing device, but I highly recommend getting these as it just makes the process more simple, fast, and connected. You will also need the Dentamile Connect software to design the trays, or you could use your own software to design, but the Dentamile Connect is nice because it has all the correct settings you need for making the trays. One cool thing about the printer is the force feedback feature. Essentially, there's a sensor inside the printer on the build platform. Force feedback can read the forces when pulling away. Think of it like pulling a suction cup. When the suction cup comes off, there's a pop. That is similar to the item being built on the tray, in the sense that as the platform raises, it can sense the layer being fully peeled off. It's like the sensor knows the suction cup is popping off. Most other printers just move a predetermined amount when finished curing each layer. Remember, when printing, each layer is cured and separates. The force feedback helps reduce elevator travel and increase print speed by making sure the layer is fully peeled away. This is a close-up of what the system looks like. You have the printer and the washing unit on the bottom and the curing unit on the top. Sorry, the printer to the left. Now let's take it step by step. First off, with some scanning.
Scanning in the chair? That's so 2021. Time to hit the streets.
This is a little fun video I made this summer.
Scanning in the chair.
Next step is the design. This is done with the Dentamile software, which is cloud-based. There's an option to delegate each task to a team member, but honestly, it's so easy and you don't need it for the whitening trays. I think the delegate task is more geared toward big pros cases, and this whole design process will take 5 minutes. So in my opinion, I wouldn't really delegate. So this is what the software looks like. If you can see, I just want to show that quickly. It's really funny to me. Oops. The birthday, you have to do it in the correct format, which is like the European way. So you have to do the date and the month and the year. So basically you just drag the STL files into the software, click next, and then you draw the 4 points on the model. It says to do it on the second molars, and I realized I just did on the first, but it still came out okay. So you do that. The most waiting is sometimes it's like a little laggy. It'll take like 5 to 10 seconds for it to load as it's like calculating stuff in progress. So this one, I did them both. I was doing this a little bit quickly, but I didn't. I'm just showing you that you can do it quickly like this, where you don't really go with the gingiva, or you could follow and scalp the gingiva. So I'll show you both ways. But this is like pretty similar to any software, any design software for that matter. And it's cool too. You can just drag the dot and move it, and then it'll show you what the tray will look like. Then you go next, and then you got to do it for the top. So I messed up the points again, but I don't think it really matters. Yeah, as I said, the calculating process is just a little bit slow, but this is real time. Okay. Now you can draw the reservoir. So the way the reservoir works, you just click left click and it goes just like that. It's pretty easy. And then you can increase the radius of the reservoir. You can increase the thickness of the reservoir. And then you can also remove parts of it or add to it. Okay, so then it calculates again. And now you'll see me here. I do a little bit better job of following the gingiva. Yeah, so that's me showing that you can just take the line and move it pretty simply. So I actually timed this whole thing. If you're doing both arches, it took me exactly 5 minutes. And that includes everything from uploading the file to designing it. It's actually pretty similar to the Splint software. I don't know if anyone uses that. um, you're pretty much making a splint with the reservoir. And you don't even have to do any occlusal. Okay. All right, there we go. Now you connect it. Go to the next step. You can also edit it from when it's blue too, if you don't like it, and you can edit the borders. Okay, so now it's calculating. And now you go to the next step, and then that will, you can either print it or you can save the file. For me, I usually just save the file and then I send it to NetFab. Okay. So now let's go to the next step. All right. So next is printing. So first, you'll want to shake the resin if it's still in the bottle before pouring it into the tray. I personally recommend a separate tray for each type of resin. If not, then you'll have to remove all the resin and put it back in the bottle and then clean it with alcohol. That's what's being done in the picture on the right. It's doable, but not ideal. Okay. So you can see here, I just literally drag the files into the NetFab software. And then you basically arrange the whitening trays on there. But remember, you want to have the occlusal surface on facing towards the platform. So you just move it like that, move it a little bit over so they're not touching. I usually like to put it in the center. You gotta use the supports. And basically, if you look to the right of the screen, you see now there's two check boxes. You want to have you want to have the 4 check marks, and then you know you're good. So for this step as well, the only slow part is when it's doing the processing. So right now it's adding the supports, and that's what's taking a little while. So I skipped that part for you. So this is me adding the supports. You can see the purple pink one has the supports, and now we're adding it to the orange one. I told you I really did this real time. Okay. And then you also need to have like a base plate. So the base plate allows the supports to stick to the printing platform, and then the supports hold on to the whitening tray itself. Okay. So this is us showing we're swapping out. This is a tray that the pink color, we use it for the gingiva. So we're swapping it out. And now we're going to add this. So that was just like very seamless. Actually, if you see here, I was messing around and a print dropped in. So this is me taking it out. So you just gotta make sure there's nothing in there. It's a little bit hard sometimes to see it with the clear. So I just took it out and then we were good. All right. So now we put it back in. Sometimes after you shake it, by the way, there might be like some bubbles and stuff. Don't worry about that. That's fine. So basically you just select the job. It's a touch screen. Those are my trays. So I select it. It said the reservoir level was low, but it was fine. So I just click confirm. And now I always like to just watch it go down a little bit, make sure it's going, and that's it. So then you can close the printer, and it takes about 22 minutes with two. Okay, perfect. So here's a picture of shaking the resin, just to remind you to do that, since I forgot to show you in the video. And then the one on the right is what the inside of the printer looks like. So this is what it looks like when the print finishes. You can also see there's RFID tags, and then you can see sometimes if you need to pour, and you actually can just pour it into the printer like that. I also want to talk a little bit about the resin here, Orthoflex. Just so you know, there's 3 key properties. First off, Orthoflex is flexible. With its low Young's modulus caused by extra long polymer chains, the material is soft and pliable enough to be in direct gingival contact without causing much irritation. Second is the durability. As a class 1 device, Orthoflex needs to be durable enough to be inserted and removed many times without tearing. Orthoflex is highly durable and tear resistant to ensure the created appliance lasts. Third, transparency. For a flexible material, Orthoflex possesses a remarkably clear finish after polishing, so you can see exactly what is happening after the device is inserted. And here is a video of the trays coming out of the printer. They'll be placed in the unit to be washed and then cured. Just ensure that no 2 parts are touching for the cure. For the wash, I like to ensure that any geometries that can trap liquid are facing down so they drain, but it's really not an issue. So here is what they look like before and after being polished. Supports should be left on during curing. They should be removed after the curing process. That can help prevent warping. You can take off the supports with a scissor, and then you can polish it with a carbide, soft rubber polisher, and then a polishing wheel.
Hey Luke, this is the lab. What are you doing?
So this is a video
We're giving
earlier
the
from
lecture
today.
tonight. Well, today's October 20th. The lecture's tonight. I've decided that every time I have a lecture, I have to do the thing one more time that I'm doing that night, just to, you know, so it's really fresh. So we're making a whitening tray right now. Trying to go for the world record of the 3D printed whitening tray. Let's see how that goes.
Oh, that's cool.
Thank you. All right.
Check in, guys.
All right, and then here's a video of me wearing the trays since I can't show my face.
All right, everyone. So these are the bleaching trays right here. I'm gonna put them back in. We just made them today. Polish them. You can see. All right. All good.
The whitening trays have huge marketing potential. I want to first show you this video on the left. It's the robot at our office called Zeno.
So just make an appointment for a week.
Hello, Susan. Please come with me. I will show you to chair 3. Tap my screen when you are ready to go. Okay. have arrived at chair 3.
Do we need Xeno for the practice to work? No, but we love Xeno. But actually, the robot is a pretty big help in getting patients to the chair while we get the chair ready. The robot is also amazing at marketing. All the kids have their phones out taking videos of the robot. This video was posted to Instagram and got over 20,000 views. Now let's apply this same concept to 3D printed whitening trays. You could make the 3D printing station like a donut shop. You could have, you know how like the donut shop has the donut maker in the window and all the kids watch their donuts being made? Why not do the same thing with 3D printers? What if you became the dentist known to 3D print your whitening trays or splints or whatever it may be? Remember the beginning of the presentation when I showed you the 3D printers can print anything. You could use a 3D printer to print cool toothpaste caps for your patients, like that Yoda one. Last year, we printed different characters from some TV show. I forget the name. And we put the office logo on it. And then we hid them all around the office for the kids to find and keep. So yeah, if you're not going to buy a printer for making whitening trays, just buy it to make random items that will make your patients happy. And then I also want to show you this picture from Dr. Kishan Godia. He makes awesome TikTok videos. And this one, I think, got like over 30,000 or something on TikTok.
How many days can you get away without wearing your retainer before your teeth will start to shift back? The answer is actually 0. This here is the Luxaprint Ortho Plus retainer. It's actually made from a light curing 3D printer resin. It has an exact fit to your teeth and it's transparent, so it's super discreet. It only takes 1 day for your teeth to start shifting back, so if you want to keep your teeth aligned, you have to wear your retainer. How many days can you...
Oops. I also would like to talk about the environmental impact of all this. It is obviously something to think about. I like to think that direct printing will help lessen the environmental impact by printing less materials and producing less waste. I'd also like to mention this program called TerraCycle. I knew them in the past because they had helped at school with recycling toothbrushes, toothpaste bottles, floss, and other dental items. They are finally moving into aligners. It's not available in every state, but if it isn't available in your state, definitely check it out and help do your part for the environment. I know patients would love it if they knew they could recycle. Okay. So remember this traditional method. Now, this is not a perfect spreadsheet. This is just like an average. And a lot of these values depend on the material that you're using and whatnot. So I wanted to briefly touch on the finances of this. These numbers are not set in stone. Haha, get it. Think of them more as an average. The point of this slide is to show that direct printing the whitening trays is slightly cheaper than stone models or doing a suck down on a 3D printed model. However, those costs will vary depending on the scanner you have or the impression material you use. And the timing is pretty similar. The nice thing is that if you can scan something, then you have it forever. You can use the STL file for multiple things. Say, for example, they need a night guard and a whitening tray. You'd only have to scan once. I guess you could take one PVS impression and then pour it up twice. I'm going off on a tangent, but you get my point. The other thing I want to point out and be honest with is that these printers cost money and there are subscription fees and whatnot. So you won't be saving money per se, but you will be saving some chair time and adding to the patient experience. Some thoughts about the future. And I think, in about 5 years, AI may be so good at designing whitening trays that we actually won't even need to use the Dentamile software to design it. We're pretty close to it now. 3Shape actually has a program called 3Shape Automate that will make crowns or splints for you using AI. You pay anywhere between $5 to $15, depending on how quickly you want the design, 10 minutes or 24 hours, and then they send you an STL file. I'm sure we will get to the point where you just need to send a scan to a software and then it's printed. No need to design, nest, or anything. Just scan and then print. So, the key takeaways from this presentation are direct printing is the future. It is finally here, and DMG is leading the effort, is one of the leaders in the effort, and it's exciting to see where it will take us. The Dentamile is a great software to use. 3D printing is here to make your life easier, make patients happier, speed up the workflow, and put the power of the lab into your hands. 3D printing is fun, but it requires studying and staying up to date. The technology is rapidly evolving, and there's so much to learn and do. Thank you for your attention. If you have any questions, please feel to email me or message me, and have a great night. Okay, just a couple questions. Someone asked, can you use an iPhone to scan? We are currently not there yet. I have heard that technology is being developed. You can use it to scan a face, but you cannot currently use an iPhone to scan teeth for 3D appliances. Any other questions? All right. Thank you all. Hope you have a great night. And thank you.